Cotangent x equals 0. Okay. This one's going to be a bit of a pain, actually. And what was the tangent 2x formula from your mighty cheat sheet?
2 tangent u over 1 minus tangent squared u.
And the u is going to become x's here, right? Mm-hmm. So 2 tangent x over 1 minus tangent squared x minus cotangent x equals 0.
Do you have them memorized?
I did. I think I've got most of the sines and cosines ones memorized, but the tangents not so much.
I don't have the tangents.
Really? You and I would be a great team. On that. Okay, so now to solve this, there's a couple different things we can do. Here's what I'm going to do first. I'm going to add cotangent x to both sides. Okay, you got to pull out the part of your brain for this that we were doing on that you were using to solve the trig identities a little while ago. Okay, but that would be the first move. Anybody have any idea what might be a good second move?
Well, tangent squared x is the same thing as 1 minus cosine 2u, or 2x over 1 plus cosine.
True, yes, but we already got the tangent 2x substituted. Once you get rid of the coefficient in front of the x, the multiples, you don't want to go back. You want to keep it all tangent and cotangent x's. It's very hard to solve otherwise. Michelle, what's your idea?
Well, that's the exact formula for this, except for that one's cotangent. So you want to, so you want to flip, you can make it into the tangent.
If this were a 2x, we could. But since it's an x, that won't work. That's a good observation, though. Layla?
Well, I was just going to suggest making the cotangent x into 1 over tangent x, but I don't know if that would do anything.
That's going to be important in a second. For the next trick I have in mind. I was thinking algebra, not trig now. Because remember, this part almost always winds up going back to algebra solutions. I'm going to multiply both sides by 1 minus tangent squared x. And after I do that, what Layla suggested is going to get to be very important. Advantage here is this cancels with this, and now I have 2 tangent x equals. Okay, now I distribute the cotangent x to each of those terms. What's cotangent x times 1?
Cotangent x.
Alright, minus, what is cotangent x? I'm going to write, Layla, I'm going to take your advice here. I'm going to write this as 1 over tangent x times tangent squared x.
Isn't that putting in a circle when you just keep on doing the same thing?
Could. So that can happen with these identities, but I don't think that's going to happen here. What's going to just happen with 1 over tangent x times tangent squared x? What's left?
Tangent squared x over tangent x.
Which will reduce, Michelle, to tangent x. So I've got 2 tangent x equals cotangent x minus tangent x. Once again, I'm going to take this cotangent x, I'm going to write it as 1 over tangent x. This is a little bit roundabout. I don't think there was a shorter way to do it, though. Is there anything else I can do to simplify this?
You cross out the tangents.
You mean this one and this one?
Yeah.
No, because they're not being multiplied. Good.
Tan 2x, I mean tan squared.
How would I make it tan squared x?
Multiplying by tangent x.
Multiplying what by tangent x?
Tangent,
Everything.
sides.
Yes, both sides. Excellent. That is my next trick. I'm going to multiply both sides by tangent x, which will get me 2 tangent squared x. What will happen when I multiply tangent x times 1 over tangent x? Close? 1. All the fractions tend to leave you with 1. And then minus what here?
Tangent x.
Tangent squared x. Okay, so this is what I get if I multiply this entire equation, every term, by tangent x. Is this starting to look like a quadratic?
Yeah.
Sort of. Okay, now I'm going to, up here, I'll show the step down here. Now I'm going to add tangent squared x to both sides, and that gets me 3 tangent squared x equals 1. Did I do that correctly?
Yeah.
These are the ones where I personally always get the trig right and tend to mess up the algebra. Alright, what can I do now to get tangent squared x by itself?
Divide them both by 3.
Divide them both by 3. So that's going to be 1/3. So then what does tangent equal?
Square.
Square root of 1/3.
Yep. Almost. You're forgetting one thing.
Root 3 over 3.
Oh, you're getting there. You're almost there.
Or no, wait, hold on. If it's root square root of 1 over 3 is the same thing as square root of 1 over the square root of 3.
Sam's moving ahead.
So it's
One
oh,
over
it's square root of
1 over root 3, and when you
so it's
rationalize
square root
that,
of 3 over 9.
Do you not want the thing on the bottom?
3 over 3.
That's right, yeah.
I left a little bit of room here
That's
for
what
a
I-
reason.
That's what I said.
Which part?
I said no. The first thing I said was
Root 3 over 3, yeah, but then you said root 3 over 9 a minute later.
yeah, but then you said you're getting there, and I was like, maybe I should do something else.
I did not mean to throw you off with that, Sam. But what's missing from this part?
What do you mean?
Take a square root of both sides here.
Oh, you have to do the root tangent. Or wait, what?
Tangent of that.
What's the square root of 4?
2.
Or
Negative 2.
plus or minus 2, right? Okay? So we've got plus or minus for each of these possibilities. When is the tangent root 3 over 3? You got your cheat sheets in front of you, but they only have sine and cosine.
Wait, so root 3 over 3.
Sam, do you remember this?
Is the same thing as
30 degrees.
it's.
30 degrees.
Well, you can do that, so.
Good try, Sam. Sam's trying to go without the cheat sheet for. Okay. On the unit circle. We're on the unit circle.
Is it also 150 degrees?
Shell, you're skipping ahead of me. You're on fire today. Excellent. Yeah, where else is the tangent?
Michelle.
Going to be,
150.
yeah, 150 is another one. But over here, is this positive or negative root 3 over 3?
Positive and not negative.
Then negative over here. Anywhere else?
Yeah.
Yeah,
It's a 30-degree angle. This will get you to 150. Where else?
210.
210. Positive or negative?
Positive.
Positive. So there's my 210-degree answer. And then anywhere else?
300.
And this is going to be positive or negative? Negative. Remember, tangent, you can always remember when it's positive or negative because it's the same thing as slope.
Root over 2.
Ha! Thank you. Excellent.
It being over 1, is that the same thing as saying it over 3?
Well, short answer is no, but I think it depends. What do you mean?
Because like on this,
Uh-huh.
technically it's over 1. Because it's like cosine over sine, which is root 3 over 1.
Did nobody catch this? Or did we do that? Did we do that backwards?
What?
No,
What if it's
I
at
mean-
60 degrees? 1/2 over root 3.
Oh, that's right. So it's the opposite.
Okay, guys. This was close, but not quite.
Wait, don't you have to put it back into cotangent?
Hold on. No, actually, we don't. For that, we don't find the solution. But is this the right answer? Is the tangent of 30 degrees really
No, it's
No,
root
that's
3 over 3?
no. That's what I was thinking because it's.
What were you thinking?
I was thinking that it's the cosecant over the secant, or it's like when you do the opposite of
What's the sine of 30 degrees?
sine of 30 is
1 over 2.
1/2. What's the cosine of 30 degrees?
Root 3 over 2.
What happens when you put 1/2 over root 3 over 2?
1 over root 3, which is root 3 over 3.
You get 1 over root 3, which is correct, so we did do this correctly.
no. Wait, I'm really confused.
Yeah, because you cancel out the 2's.
Yeah, these 2's cancel.
Okay.
And then
The
you
bottom.
multiply-
Okay.
But it's
Don't you
still
multiply
really-
Good double checking. You made me double check myself,
But
which is
isn't it
good.
still root 3 over 1?
No,
No, because
it's
then
not.
Oh, because you just don't
Three
flip
root
it. You
three
have to
over-
flip
Yeah,
it. Okay.
the way we get from here, we didn't flip it, we rationalized by multiplying the top and bottom by square root of 3.
Okay.
Alright? Okay. That was a tricky one. That was a difficult one. Now for the good news. Yeah, any
How
questions
do
on
you
this
prove
one?
it? The thing you did at the very end?
This one?
Don't
Yeah.
say that.
Okay, we don't like rationals on the bottom, right?
Right.
So we multiply the bottom by square root of 3, because the square root of 3 times the square root of 3 gets rid of the radical sign.
Right.
Just get 3. But you're not allowed to just multiply the bottom of